So topic light question 3 figure 1.1 shows his trace sheet at full size. You can see a ray trace sheet is there, a mirror is placed, a lamp is there. So first one, the student carries out an initial experiment. He draw a line AB and CD as shown. So first what he did, he draw the line AB and he draw the line CD as it is shown. Then he draw a line EF. So he draw the line EF through the point N as shown in a figure 1.1 and at an angle theta. What you have to do, you have to measure the angle theta. So how you can measure this angle theta? You just have to place because you want this angle. So either you can place a protractor in this manner and read the scale, or you can also place in the other way around. So this will be 0 and 1, 2, 3, so on. Read this scale. So you have to place a protractor and read the scale because we need angle between the line AB and line like A and E, this angle we need. You just have to use like your measurement and write the answer here. So this angle approximately, will use approximation here as we are not measuring. So it will be about like 22 or 23. So you will write here 23 and degrees. Then draw a normal to line AB at a point N and extend the normal to line CD. And label the point at the normal as which the normal crosses line CD as L. So what we have to do, we have to draw a normal for line AB. Normal is always perpendicular to the surface at the point N, and we have to extend until it meet the line CD, and we have to label that as L. So this one is AB. So you can see this one is line AB. And this is point N. So what we have to do, we have to draw a normal to the line AB. So normal is always perpendicular. So if this is a line, so 90 degree we have to draw. And we have to continue this line until it meet a point on line CD. And we have to label that point as L. So don't forget to mark those points as they mentioned, because sometimes we have to measure the length. So this is N and L, and L is the point where the line crosses or line touch C and D, or it meets C and D. The next page, the student placed a plane mirror on line EF. So what he did, student placed a plane mirror on this line. And a screen is there, which is 2 millimeter slit on the line CD. So he placed a screen here with a slit. And he arranged the screen so that the ray of a light shines along L and N. So light is passing along L and N through this slit. And the ray is reflected from the mirror. So what student did, student placed a mirror here, as I mentioned on line E and F. And there's a screen is placed which is having a slit, means there is an opening. And what he observed the reflection of a light from the lamp passes through a slit, strike the mirror, and it will bounce back. And the direction in which the light bounces back, that direction is P. But we don't have to draw anything right now, as I did not mention. This is just an experiment in which the experimental setup is there. The ray is reflected from the mirror and passes through point N. State and explain whether point N shown on the figure 1.1 is suitable distance from N to this investigation. So how we can identify whether a point is a correct distance or no? When you're marking a point, for example, if we have a mirror and we want to trace the path of a ray of light, say this is representing a mirror. So if you want to trace, and this one is a lamp with one opening and the light is passing through the slit. The light is passing through the slit, the light strike the mirror and the light bounce back. So this is the direction bounce back. If you want to trace the path of the light what are the suitable distances if we want to mark a position, 2 points which are showing the passage of the light. So these 2 points which we use, they should be 5 centimeter apart from each other for an accurate measurement. Minimum 5 centimeter. More is acceptable, but not less than 5. But when we want to trace the path of a light which bounce back from the mirror, so the points, one of the points should be closer to the mirror, so we can easily locate the initial direction. So one of the points should be closer to the mirror, and the next point what we mark should be 5 centimeter from the first point. So the gap or the distance between the 2 points should be 5 centimeter. And when we are tracing the location of a light which strike or which bounce back, that point should be closer to the mirror. So if you see in the question, the point P that student locate, like what is happening in this experiment, the light is passing through the slit, from the lamp through the slit and bounce back, and it is passing through point P. Does it look accurate, the position of point P? Yes or no? Is it closer to the mirror?
No.
So it's not closer to the mirror, so we'll say this point is not suitable. What should be the position of the P? The point P should be somewhat here, very close to the mirror. And if they say mark another point for to trace the passage or the path of a light, then the other point should be 5 centimeter from the first point. So that is the question here, as they ask, state and explain whether a point P distance between the pin. This experiment can be done. There are two ways we are doing an experiment. One is an optical pin method, another one is a ray box. In a ray box method, we don't have pin. In a ray box method, we just mark the position on the points on the ray of a light in a dark room. And in a optical pin method, we place a pin. So this is a ray box method, not an optical pin. That's why this P is not a pin. This is just a point which we mark, because in a dark room, when we perform this experiment, we'll find the light strike the mirror and light bounce back. So we will see the passage of the light. And then to locate the position of a ray, so we mark the points, one closer to the mirror, and the other point 5 centimeter. Same thing, one closer to the mirror, another one 5 centimeter. So these are the points we mark. These are not pins. Pin method is in which we don't use a lamp. So we'll say no. And what is the reason for that explanation? We should mention that P should be closer to the mirror. Then part C, draw a line joining point N and P and extend until it meets line CD, and label the point with the letter G and measure the length of LG. This, ray box method should be done in a dark room. If it's an optical pin method in which we use pins to use an object and an image, that should be done in a lab. But the ray box method, the experiment of a light which we use a lamp, should always be done in a dark room. Same thing, the experiment in which we form image by a convex lens should also be done in a dark room. So this line we already do. That was a normal we did in the beginning. That was we said as L, and then they're saying draw a line joining N and P and continue until it meet line C and D. And the point or the position where it meet line C and D, we label that as G. And then we have to measure the length of LG. Like after drawing this line, you just have to use a ruler scale and measure the length. Example, we are just taking values. You just have to measure, say, it was coming out 10 centimeter or 10.2 or 10.3 centimeter. Any value it can be. The next one, the student repeat the procedure with the different angles. You can see the student did with angle 25, 20, 15, 10, and 5. And he got the value for 8, 12.2, 8.3. These values are the student plotted, and then from these values you have to plot the graph only and find the gradient of the graph. So I just add graph part. I included another question I removed from this one, but this question just to explain the trace of a ray, how the ray of a light is passing. So how it is passing through. How to measure L and G? What you have to do, you have to place your ruler or the scale, like you draw a line from N to P and continue until it meet a point CD, point on line CD. And you have to place your ruler or the scale next to this and measure this length. Like you place your scale ruler next to this line and measure the length of the line. This measurement is there. This one is L, this is NG, and this one is LNG. No, this one is NG and you want to measure LNG, so you will place here. This is LNG. So in the question, as I mentioned, you have to draw a line joining N and P and extend it till it reaches CD and label that as G and measure the distance between L and G. So first, when you draw normal for AB, you label the point where it crosses CD, you label that point as L. And then you draw a line. Then you draw the line joining from N to P and you label that as G. And the question is measure the length LG. So you have to just place your ruler scale here and measure the distance, this line, L and G. So another question from the same topic, light. The class is investigating the refraction of a light through a transparent block. A student use optic pins. So when a student use optic pins, so this should not be done in a dark room because we just place the pin as an object and we identify the position of the pins by using another 2 or 3 pins as an image. So what student, this is a trace. A student place a rectangular block. Again, you have to follow the instruction on a figure 2.1, draw a normal at the center of AB and label this as N and L. And label the point E where the normal crosses AB and label the point M where the normal crosses CD. So what you have to do at the center of this, like you will measure this length, say this is 4 centimeter or 3 centimeter. So at the center, like it will be 1.5, it was 4, then it will be 2. You will draw a line, normal will be there. And the name of the normal, as I mentioned, it is NL. So we label the normal as N and L. One point of a normal is N and the other point is L. And the point where the normal cross A and B, that we label as E, and where it crosses C and D, that we call that M. So one of the point we label that is E, and the other point we label as M, where it crosses C and D. Then label the 2 pins P1 and P3. Label the position of 2 pins P1 and P2. And the thing is, the second point, draw a line above AB to the left of the normal at an angle of incidence 30 and label the line as FE. So at an angle of 30 degrees incident. So this was the first thing what we did. Yeah, N and L should be perpendicular because it is a normal. Normal should always be perpendicular or 90 degree to the surface. Then what we have to do, as I mentioned, on the left of this, as I mentioned in the question, on the left of this, we have to draw another line. And the angle of the incident should be 30. So you place your protractor mark 30 degrees and draw the line at an angle of 30. This length of a line they did not specify, so you can draw any length, but the angle they specify, that should be 30. So this angle should be 30 degrees. And you will label that as E and F and E. So this one is F, one point of this one is F, another point is E. E is already there. So you have to draw another line at an angle of 30 degrees and mark the other point of the line as F. Is it clear till this point? How to draw a 30-degree?
Yes, sir, clear.
Then the student observed the image, then the label two positions of the pin and place suitable distance. So we have to place two pins, as I mentioned, P1 and P2, at a suitable distance. So as I mentioned, whenever we place the pins, one of the pins should be closer to the reflecting or a refracting surface. So one of the pins should be closer. And what about the second pin? When we locate the second pin, it should be 5 centimeter from the first one. So measure 5 centimeter distance and place the second pin. Is it clear? And it can be, the order can be different. Order can be P1 can be this one and P2. As they did not mention, P1 is closer and P2 is away. So order can be different. This can be P1, the other one will be P2. So it won't make difference. But the idea is that one of the pins should be closer to the refracting surface, another one is 5 centimeter apart. Like two pins should be 5 centimeter apart, and the one of the pins should be closer to a reflecting or a refracting surface. If your this length is, like example, shorter than 5, so extend the line, because they did not specify that this line is what is the length of this line. So you can extend this line. For example, if you try to locate the position and you don't get 5 centimeters, so you can extend your line and then point F will be here. So but the distance between the pins should be 5 centimeter. When student observe the images of P1 and P2, student observe the images of P1 and P2 through the side C and D, so that the image P1, P2 appear one back or behind the other. And he places two more pins, P3 and P4. Draw a line joining P3 and P4 until continue until it meet the normal and label that as K. So what we have to do, we have to draw a line which is joining P3 and P4. Like this is P3 and P4. We have to draw a line and we have to continue this line until it meet a normal. So the position or the point, you have to follow the instructions. So until it meet a normal, you label that point as K. That is the question. So join the line, join the position P3 and P4 by a line, and the point or the position where it intersects the normal, we label that as K. Then measure and record the angle alpha between the line joining the position P3 and P4 and the line KM. So we want to record the line joining P3 and P4 and the KM. So we have to record this angle and we call that as alpha. So label on the diagram. So this is alpha. And how you can measure this alpha? So you will place a protractor. Like this will be 0 and measure this angle value. And you have to record that value on the, so value of alpha according to the measurement, you will, because you will measure and write what is the value for alpha. It can be any number. Example, we say 25, 30. So it is 25 or 30 is there. Then measure and record the length X between N, M and K. So we have to measure how you will know where to place a protractor. Depend on, for example, I'm measuring the angle between the two lines. Say I'm measuring the angle between these two lines. So one of the line I have to use as a base. Like if I use this line as a base, this line I'm using as a base, so protector will be placed in this manner. The line which we are using a base, the zero of the protector should be on that line. Or if I use a second line as a base, if I use this one as a base, so I place a protector other way around, and that will be zero. So it won't make difference to the value. So we have to measure in the question, we have to measure the x, the distance between M and K. So we have to measure this length using your scale. You will measure this length and mention either like in centimeter or a millimeter, depending on, sometimes they give the unit, so it must be in that unit. Here they did not mention, so you can write your answer in millimeter or centimeter. Then in part D, student repeat the procedure with an angle of incidence 52 and he got alpha, angle of incidence 50 and he got alpha as 52. The student suggests that the angle alpha should be equal to the angle of the incidence. So student is saying that angle of incidence should be equal to alpha. That is a student conclusion. Like the statement is there. You state whether the results support this suggestion and justify your answer with reference to. So how we can justify our answer with reference to whether alpha and angle of incidence are equal. So what was the angle of incidence? Angle of incidence was 50. And what is the value of the alpha? Value of the alpha is 52. Are the two values equal? Can I say that angle of the incidence and alpha are equal? So how we can identify? I have to work out the percentage difference. If the percentage difference between the two values, when we work out the percentage difference, the difference between the two values, if the percentage difference between the two values is more than 10%, then we say no, the values are not equal. They are beyond the limit. But if the percentage difference between the two values is less than or equal to 10%, then we'll say they are within the limit. So if I want to identify whether the angle of the incidence, which is 50, and alpha is 52, whether the two values are equal, I can work out the percentage. We can check with any, because they mentioned for angle of incidence of 30 and angle of incidence 50, we have to work out the angle of the refraction. So if our value of angle of incidence was 30 and our alpha was 30, so the two values are equal, we'll say yes. We don't have to even calculate the percentage difference. We'll say yes, the two values are equal within limit of experimental accuracy. But if two values, like if you're not able to conclude whether they are equal or no, one of the values, example 50 was there, and the other value is 52, and you want to check whether the values are equal or no. So you will always calculate the percentage difference. How to calculate a percentage difference? It is a maximum value minus the minimum value divided by mean into 100. That's how we calculate the percentage difference. Maximum minus minimum divided by mean into 100. If the percentage difference is less than or equal to 10%, the values are equal. If it is more than 10%, the values are not equal. So we are comparing example 50 and 52. So maximum value is 52. So maximum value is 52, minimum value is 50, and divided by mean, the average of the two is 51 into 100. When you simplify, what's the answer? 52 minus 50 divided by 51 into 100. What's the answer for this? 3.9. Okay. So that is 3.9%. So if our percentage difference is 3.9, what we'll say, yes or no? So we'll say yes. The values within limit of experimental accuracy, the values are equal. Or the two values are within limit of experimental accuracy. Or we can say angle of incidence 50 is approximately equal to angle of alpha 52. Then state one precaution that you would take in with this experiment for a reliable result? For an optical pin method, what are the precautions we should take for optical pin? We should use large distance between the pins. We should always look perpendicular, view the base of the pin, and use the thin pins or thin lines. So these are some precautions you should take, like use large spacing between the pins, look perpendicular, we will view the base of the pin. If the percentage difference is more than 10%, that time you will say beyond the limit of experimental accuracy. If it is less than or equal to 10%, you will say within the limits. So use large spacing, you should look perpendicular, you should view the base of the pin, use thin pins or lines. When you're tracing the passage or the path of a ray, you should use thin lines and thin pins.